Good day, everyone. My name is Mr. Ademojimi Adedotun. What we're looking at today is surds. What do you mean by surd? Surds are the numbers that can be expressed in square root sign. Numbers that can be expressed in what? In square root sign. E.g., when you have root 5, root 2, root 3, root 11, root 12, root 15, and so on and so forth. All those numbers can be what? Expressed in what? In square root sign. Of course, you know what square root sign is. This is the symbol for what? For square root. Okay? There are two classes of surds. There are two classes of surd. Two classes of surd. We have rational. We have rational. And we have what? Irrational. Rational and irrational. Rational and irrational. What do you mean by rational? Rational are the numbers that can be expressed in form of A over B. In form of A over B. Any number that can be expressed in this form, such that we have the numerator and the denominator. Such that we have numerator and denominator, such numbers can be what? Referred to as rational number. Examples are 0.5, 0.25, 0.5, 3 over 7, and what? 3 over what? Over 10, etc. etc. Okay? Example are what? 0.25, 0.5. Then you ask that what is 0.25 doing in what? In this? Yes, this is the word decimal. What do you mean by decimal? Decimal are what? Are fractions that what their denominator is in form of what? Of 10, 100, 1,000, and so on and so forth. Okay? You can still take this one to this form. When you have 0.5 is 25 over 100 over 100. That is 1 over 4 in fraction. Okay? So what do you mean by rational? Irrational are the numbers that cannot be what? Be expressed. That cannot be expressed in form of A over B. It means that rational numbers are what? The opposite of rational. Any number that cannot be expressed in what? In form of B are called what? Irrational numbers. So example are when you have your pi. Your pi is 20 over 7 and you divide it, we give it 3.142, 3.142, 5, 6, 7, 8, and so on and so forth. We have also the cube root of 2. That will also give you what? Irrational number. And what again? We have this. We have this. This is what we call, this is pi. That's pi. This is what we call what? Euler constant. Euler constant, which is 2.718, so on and so forth. Okay? So that is that. So let's look at what the logs or the theories. Yes, I love using theories. Let's look at the theories. A, or the first theory, says that if you have root A times root B, that will give us root AB. Root AB. 2, when you have root A plus root B plus root A, that will give us 2 root A, root 2 root A. The third one, if you have root A upon B, root A upon B, we give you what? Root A upon root B. Okay? The fourth one, if you have root A times root what? Times root B, okay, times root A, that will give you what? A. Root A times root A will give you A. Okay? Or you can still say what? A raised to power 2. Okay? And the 2 will what? We cancel the sign, the square root sign. So it will be left with what? With A. Okay? And let's look at this. Note that what? The fifth one, which is what? Which is root what? Root A plus root B is not equals to what? Is not equals to 2 root AB. Is not equals to. This is not equals to this. Is not equals to this. As I say, is not equals to. So let's look at what? One example under the one, the first theory. If you have root 5 times root 2, what would that be? That will give you root what? Root 5 times what? 2. And that will be what? Root 10. Thank you. So the second one, if you have what? Root 5 plus root 5. What? Yes, they are the same. Look at this. A. They are the same. Equal surd. Equal surd. Same surd. Same surd. This will give you 2 root what? Root 5. Take note. And likewise this also. If you have root what? You can see over what? Over 2. Okay? That is, when you have something like this, root 3 over 2, you can see that what? The square root sign covers what? Everything. Covers what? 3 and 2. It means that this sign does not what? Belongs to what? To 3 only. Neither what? Does the sign what? Belongs to what? To 2 only. So if you are what? To separate them. So that will become what? Root 3 upon what? Root 2. Alright. Alright. Okay. So based on the fourth law, if you have root 2 times root 2, that will give you what? 2. Yes. Root 2 times root 2 is 4 and square root of 4 is 2. Okay? That's that. So let's quickly move to what? To difference of what? Of 2 squared on the days. Difference of 2 squared on the days. Difference of 2 squared. Difference of 2 squared. Difference of 2 squared. When you say difference talks about minus. 2 talks about what we are talking about. 2 numbers. 2 variables. That is, if you have a raised to the power of 2 minus b squared. A raised to the power of 2 minus b squared, you can see the difference there talk about what's negative. That's a minus. The difference between the 2 variables. Okay? Difference of 2 squared. Meaning that what this is still the same thing as a plus b, a minus b, a plus b, a minus b, a plus b, a minus b. That's it. From difference of 2 squared. Okay, comparing this now, meaning that what? Hello, if you have what? A, if you look at what? If you consider the 2 brackets, we have in what? The same what? Variable inside, but different what? Different what? Sign. So that's just what? The scope. Okay? Once you have the same variable, but different sign, meaning that what will happen? That's different of 2 squared. That's different of 2 squared. Alright? Let's just look at what? One example under this. If you have 5 square minus what? Minus 4 square. What would this be? This will be following the same rule. That will be what? 5. 5 minus 5 plus 4. And what? 5 minus 4. This will give you 9 times 1. That is 9. Okay? So that's 9. This is different of 2 squared. And if you like square this, 5 raised to the power 2 is 25. 4 raised to the power 2 is 16. 25 minus 16, that will give you 9. Alright? Then how does it relate to what? To what we are doing? Then if you look at this, if you have, we have root 5. Okay? Okay, let's use root A. Root A plus root B, another bracket, root A minus root B. Alright, this is different of 2 squared. Because considering the what? The 2 brackets. Looking at the 2 brackets, they are having the same one, the same variables. Yes, this is root A, this is root A, root B, this is root B. The only difference between them is what? Is their signs. You can see. That's the sign. We have a positive here, where we have what? Negative here. So if you have to want to tidy up this, what would this become? Using the same what? The same process. This will become what? Root A or what? Or squared minus root B or what? All squared. This is minus. Alright? Okay, this we cancel this. We have reason for that. This we also cancel this. Okay? And there's a reason for that. Okay? Let me quickly back that up. Simply because, if you have root A, all raised to the power of 2 is A raised to the power of everything raised to the power of 2. Yes or no? When you have half. When you have root, it means raised to the power of half. Okay, now you know that this and this will cancel. Okay, that will become what? A raised to the power 1, which is A. That's A minus B. Okay? Let's quickly move to what? To conjugate. Conjugate of surds. Conjugate of surds. Conjugate of surds. What do we mean by conjugate? Let's say for example that we have question 1. We have root A plus what? Root B. Find the conjugate. Find the conjugate. of what? The following. Find the conjugate of the following. A, we have root A plus root what? B. B, we have 3 root 5 plus root 2. C, we have 2 root 3 minus what? Minus root 5. D, we have 5 root 7 minus root 6. What? Yes. We want to look for the conjugate of this. What do we mean by conjugate? We need another number like this, such that their product will give us what? Difference of what? Of 2 squared. Yes. Such that their products, the final answer will be in form of this. This is gotten from where? From product of 2 squared. Difference of 2 squared. From difference of 2 squared. Okay? Equals to, and what is the number? Is just root A minus root B. That will be the conjugate of this. The conjugate of this is root A minus B. That will be the conjugate. While the conjugate of this will be 3 root 5 minus what? Minus root 2. That will be what? The conjugate. While the conjugate of this will be 2 root what? Root 5 plus what? Root 3 plus root 5. While the conjugate of this will be 5 root 7 plus root 6. Okay? So, if you look at what the product of these two now, it will lead to what? That's different of 2 squared. Alright? The product, that is 5 root 7 minus root 6, together with what? 5 root 7 minus root 6, this is plus. So, this will be plus. Can you see that? So this is different of 2 squared. Because if you look at what you have in the 2 brackets, they are the same. They are the same. The only difference there is what? Sign. Just take notes. Okay? Take notes. Take notes. So let's quickly move to what? To the last part, which I called what? Which I called rationalization. Rationalization. Rationalization of Surds. Rationalization of Surds. Rationalization of Surds. So let's say for instance that we have 1 over what? Root A plus root B. And we want to rationalize this. That is, we need what? One number such that the product of the number and this must be the same. Must be the same thing as this. That is, if you have 1 over root A plus root B times 1 over 1, we still give you what? The same thing. Math is a forward and a backward process. 1 over root A plus root B still equals to this times 1 over 1. We have not changed anything. See the same thing. Because 1 times 1 will give us 1, root A plus B times 1 will give us root A plus B. We have not changed anything. Then we will now look for what? For the number that must give us this, such that the product must also what? Give us this. The only number we can use is to consider the denominator of this fraction. Okay? And what's in the denominator? The denominator is root A plus root B. Then we now say what? Multiply this by what? By the conjugate of the denominator. And what's the conjugate of denominator? From conjugate. So that will be root A minus root B. Everything over root A minus root B. You can see that? Root A minus root B divided by root A minus root B will give us 1. 1 times this will give you this. Are we together? So from here we can say this is equals to root A minus what? Minus root B. Everything over, we have this. What do you have there? Root A plus what? Root B. Okay, root A minus what? Root B. And what will come to your mind is, can't we cancel this and this? Don't lie. That is what will come to your mind. Can't you cancel this and this? No. If you cancel this and this, you are going back to what? To the question. And you are asking what to reduce the question, not to what to complicate it. Okay? So please don't cancel this and this, because canceling this and this will go back to this. This here 1, this here 1. So this is the 1 here, and the numerator. Why this times 1 will give us this? So we are not solving anything. So what will this now be? That will give us root A minus root B. Everything over. This is different of 2 squared. Yes. Whenever you see 2 brackets, 2 different brackets, what you just have to do is consider what you have in the two what bracket. Are they the same? If they are the same, that's different of two square. Now look at it. Root A. One. Root B. Wow, good. Then let's look at the sign together. Plus, minus. They are not the same. They are different. So that is different of two square. So we can say, well, what would this be? That would be what root A or 1 square minus root 1b or 1 square. So what would that be? That would be root A minus 1 root b, everything over what? Over A minus b. Alright. Let's move further. See on what? On conjugate. Sorry, on rationalization. Okay? Let's say for instance that we have 1 over root 3. 1 over root 3. Normally in mathematics, the denominator of your final answer must not be in a short form. Must not. It's a must. So it's very important. Yes, very important. Very important. The denominator must not be in short form. So since we're having this denominator to be what? In short form, we do what we call what? We rationalize it by what? By looking for a number such that the product, when we multiply the number with what? With 1 over root 3 must also give us 1 over root 3. Yes. Alright? So what would this be? This will be equal to 1 over root 3 times what? We can pick 2 and 2. Okay? If you pick 2 and 2, this and this will go. Say 1. Okay? But if you pick 2 and 2, you know, this and this will go. That's 1. Multiply 1 by this. We are still getting it. Okay? It means that we have not even done anything yet. Alright, but the best thing to do is you want to consider the denominator. That is root 3 over what? Over root 3. Can you see that? Times root 3 over root 3. This cancel this. This cancel this is 1 times. This will give us this. Okay, so that will be what? 1 times root 3. Everything upon. We have root 3 times 1 times root 3. From that law that we have, root A times root A will give us A. Yes or no? So we can have root 3 times 1, that will be root 3 over what? Over 3. Yes or no? And don't allow your hand to use you by saying this will cancel this. No. This will be the final answer. Let's move further. Okay, let's look at this. Example 1. Example 1, now question 1, okay? Example 1, rationalize what? Root 2 upon root 3 minus root 2. Look at this. This is root 2 upon root 3 minus. Don't cancel this and this. No. Because of the minus there. The minus is just like a what? A bond. A kind of force. Joining root 3 and root 2 together. What God are joined together, let no man put and. Please. You can't cancel this and this. So the best thing to do is what? To consider. You look for what? The denominator. The conjugate of the denominator. And we have, what do you have there? We have root 2. Root 2 upon what? Upon root 3 minus what? Or minus root 2 times 1 over 1. We have not changed anything. Yes or no? Yes. Okay. So what will be the conjugate of the denominator? That will be root 3 plus what? Plus root 2 upon what? Upon root 3 plus what? Plus root 2. Yes. This by this will give us 1. Multiply by this will give us this. Okay. This equals to, that will be root 2 into bracket root 3 plus what? Plus root 2 close the bracket, everything over what you have here. Root 3. Alright, minus root 2. Root 3 plus what? Root 2 equals to, open the bracket. This will give you what? Root 6. Yes. You remember? If you have root A times root B, that will be root A times B. That's root AB. Yes or no? Yes. Alright. That's root 6 plus what would this be? Root 2 times root 2. That's 2. Same sort. Upon what? Difference of 2 squared. Consider what you have in the 2 bracket. They are the same. The only difference there is what? Is the what? The signs. So they have a different sign. So what would that be? That's difference of 2 squared. And if you want to do it also, you can still try to open the bracket. But opening the bracket, you are wasting your what? Your precious time. And no time. So this will be root 3 all to the power of 2 minus root 2 all to the power of 2. That becomes root 6. Or you can say what? 2 plus root 6. Of course, still the same thing. Root 6 plus 2 is still the same thing as 2 plus 6. Root 6 plus 2 is still the same thing as 2 plus root 6. Just like we have 2 plus 3, 5. 2 plus 3, 5. And 3 plus 2 will still give you 5. Everything upon this and this will go, that will give 3 minus this and this will go, will give you 2. That give 2 plus root 6. Everything upon what? 1, right? 3 minus 3 is 1. That is what? 2 plus root 6. That will be the final answer. Alright, let's quickly look at this also. Let's look at this. Question 2. Simplify with what? Root 98 minus root 50. No, minus root 72. Everything over root 50. What? Yes, this is very, very simple. Okay, what you just have to do is to look for 2 numbers such that what the product of the 2 numbers will give you what? 98. Out of the 2 numbers, there must be a perfect square there. That is, there must be a perfect number. What do you mean by perfect number? Perfect number is the what? Is an odd number that what? That its square root is also what? Odd number. Examples are what? 4. 4 is a perfect number. 4 is an odd number. Square root of 4 is 2. 9 is a perfect number. 9 is an odd number. Square root of 9 is what? Is 3. 16 is a perfect number. Square root of 9 is 4. 25 is a perfect number. 36 perfect. 49 perfect. 64 perfect. 81 perfect. 100 perfect. 121 perfect. And we have what? 144 perfect. We have 169 perfect. We have 225 perfect. We have 625 perfect. etc. Okay, etc. So we can say what? Okay, we can say solution. So we can have root what? Root 98 minus root 72 upon root 50. That's equals to root. We need 2 numbers. That will be what? 49 times 2. Yes. Out of the 2 numbers, there must be what? A perfect square. 49 is a perfect square. Yes. Square root of 49 is 7. Okay? Minus root, what do you have there? 72. 72 is 36 times 2. Yes. 36 is a perfect number. Everything upon what do you have there? Now, look at 50. We can say 5 times 10 will give us 50. 5 is not a perfect number. 10 is not a perfect number. Okay? But we can have 25 times 2. Yes. 25 times 1 times 2. That will give you 50. 25 is a perfect number. So we can have square root of 49 times square root of 2 minus square root of 36 times square root of 2. Everything over square root of 25 times square root of 2, which is equal to square root of 49 is 7. 7 root 2 minus this is 36 root 2 upon this is 5 root what? Root 2. Okay? Okay. What's? Oh, sorry. This is 6. That's 6. Square root of 36 is 6. Okay, 7 root 2 minus 6 root 2. That will give you 1 root 2. That is root 2. Upon what do you have here? 5 root 2. Alright. This and this will go. What would that be? So if you left it 1 over 5, this and this will go. Take notes. 7 root 2 minus 6 root 2 will give you root 2. Now let me justify that. Because what? If you have 7 root 2 minus 6 root 2, you can decide to factorize, bringing out the common factor. What is common there? 2 root 2 is common. Don't say 2. 2 is not common. There's a difference between root 2 and 2. Okay? Root 2 is common. To be left with what here? 7 minus 6, isn't it? 7 minus 6 is 1. 1 times root 2, that will give us root 2. Do you understand that? Okay, now let's quickly look at the last question. So this is, if you are very, very well conversant with your, not WAEC question, but POST-UTME, you are very, very conversant with it. OAU, to be precise. You see this question there. You have to simplify. Now, 2018, yes. OAU post-UTME, OAU post-UTME, UTME 2018, 2018. They also simplify. Simply what? Simplify. What? Root 5. Root 5. Root 5. What is this? Yes. They are going to simplify it. Okay? There are two ways of solving this. I'll give you the normal way, then we'll look at what? The OBJ approach method. Okay? How to attempt this, under what? 1 second or 2 seconds. But let's look at the normal method first. Normal method. This is equals to what do you have here? In order to solve this, you start from the inside. From the inside. That is from what? The one that we're having inside. Inside. So that will give you what? 5. That's root 5. Root, what is this? 5 times 5 raised to power half. Yes. Root 5 is 5 raised to power half. Yes. Okay, now this is raised to power 1. That will be 5 raised to power 1 because they are having the same base. Your indices, whenever they are having the same base, you pick how many, you pick 1, then you add the part together. Why? Because it's multiplication. That's 1 over 2. That will give you 5 raised to power 1. That's 3 over 2. That's 3 over 2. Yes, now you do for the LCM. The LCM is 2. How many 1 can we say 2 is 2? 2 times 1 is 2 plus. How many 2 can we say 2? 1 times 1 is 1. 2 plus 1 is 3. Yeah, that's 5 raised to power that. Okay? We can have this equals to, what do you have here? 5 root what? What do you have here? That will be 5 raised to power what? 5 raised to power 3 over 2. Yes. And from there we can have this guy to be root what? Root 5 times 5 raised to power. So normally we have root 5 raised to power 3 over 2. 3 over 2. And that will give you what? Because of this is half, just because of this. This is half. So that will be 5 raised to power 3 over 2 times 1 over 2. Yes or no? Yes. Yes or no? Yes. So that will give us what? 5 raised to power 3 times 1 is 3. And over 4. Over 4. That will give us what? 3 upon 4. 3 upon 4. This is 1. Okay? Same rule. Same rule as this. So that will be 5. Look for the LCM. That will be the LCM is 4. How many 1 can we say in 4 is 1. 1 times 1. How many 1 can we say in 4? 4 times 1 is 4 plus how many 4 can we say in this? That's 1 times 3. That's 7. That will give us root what? Root 5 raised to power 7 over 4. Okay, which is still the same thing as 5 raised to power 7 over 4 times 1 over 2. That will give us 5 raised to power 7 over 8. This is the answer. Okay, now let's go. A liter. A liter. A liter means what? Alternative. Simply known as method 2. Method 2. Method 2. Method 2. Method 2. So we have root 5. Root 5. Root 5. Yeah. What will be the answer? Very simple. Very simple. What I want to do now is just write the answer directly. Okay? Let's assume that we don't even know what the answer is. Okay? What do you have here? 5, right? You just write out 5. If you have 7 there, you write out 7. If you have 2, write out 2. If you have 3, you write out 3. Okay? Then, if you are talking about square root, we are talking about 2. Okay? 2. Then you put this division sign. We are talking about 2. Then 2 raised to the power of how many 5 do we have there? We have 3 5s. So that will be 2 raised to the power of 3. That will give us 8. Please, 2 raised to the power 3 is not equal to 2 times 3. It's 2 times 2 times 2 that gives 8. Okay, that will be 2 raised to the power what? Oh, sorry, that will be 8. 2 raised to the power 3. That is 8. This will not be what? 8 minus 1. That constant 1 is constant. 1 is constant. So this will give you what? 5 to the power of 7 over 8. You see that equal. So you can try this on your own. Try this. 7 root what? 7. And this will be root 7. You try this. Let me just give you the answer. The answer is 7 to the power of what? To the power of. You use this method. Okay? You can equally use this method. To the power of what? 8 and what? And 7. That would be 7 raised to power that. Let's see, 7. 2 raised to power 3. That's 8. 8 minus 1. Yes, this will be the answer. Okay? Thank you and God bless you. Keep watching this station. Thank you.